You are welcome to today's lesson in elective maths on the topic matrices. I am Mr. Philip Edgin, Brainbox. Let's begin with the definition of matrix. Matrices are represented by rows and columns. Take a look at how it is written. The number on rows are written first before columns. Study this in the various types of matrices below. In row matrices, entries or numbers are horizontally written, and in column matrices, entries or numbers are vertically written. Two matrices are said to be equal if their entries are the same. For example, these two matrices are equal because the first entry is 10, which means x is equal to 1. Based on this, find the value of the missing letters in the following matrices. To add or subtract matrices, add or subtract the corresponding entries. In the example below, the first entry is 1. Its corresponding in the second matrix is 2, adding up to give you 3. The second entry is 2 and the corresponding is 5, adding up to give you 7, and so on and so forth. To multiply matrices, the row of the first matrix multiplies the column of the second matrix. In the example below, A multiplies X added to C times Y. Then again, B multiplies X added to D times Y. Let's take an example. In this example, you could see that neg 1 multiplies 9 added to 4 times 6. Now, follow the multiplication in this example. Neg 1 multiplies 9, 4 multiplies 6, and then the other side of it, neg 1 multiplies 3 added to 4 multiplying 1. Down of it, 2 multiplies 9 added to 3 multiplying 6. And then the final aspect, we have 2 multiplying neg 3 added to 3 multiplying 1. Follow the pattern carefully. Determinant of matrices. When a matrix A is given to you, and you are asked to find det A or determinant A, just multiply the first diagonal and the second diagonal and subtract the two. So you could see that A multiplies D minus B multiplies C. The order of multiplication is constant. A singular matrix is a matrix with determinant equals 0. Adjoint of a matrix. To find the adjoint of a given matrix, interchange the position of the first diagonal and negate the second diagonal. In this example, A and D interchange positions, C and B are negated. Now let's continue with finding the inverse of a matrix. Study the formula below. You could see from the formula that you need the determinant of a given matrix and you also need the adjoint. So according to this formula, the determinant is inversed. So 1 over determinant times the adjoint. When you multiply a matrix by its own inverse, the product is an identity matrix or 1. We use this property to eliminate a matrix from a given simultaneous equation. Let's look at how to solve simultaneous equation using the inverse method. Write the given simultaneous equation in matrix form to get 3 different matrices: the coefficient matrix, variable matrix, and the constant matrix. Let's take for example this equation. We have the variables as x and y, and they have the coefficient as 2, 5, 3, and 1. So we form 3 different equations with coefficient, that is a, variable, that is x, and a constant, that is b. Now we are supposed to find the values of the variables x and y. So what we need to do is to eliminate the matrix A by multiplying both sides of the equation with the inverse of A. Go through how this is done in this slide. Find the inverse of A and multiply both sides of the equation by its inverse. This will give you A times its own inverse, and that will eliminate the matrix A for you. From the final equation, if you want to find the variables of x and y, just multiply the inverse of A by the constant matrix. Go through this and complete it. Now in this example, the coefficient matrix is A. To find the variable matrices x and y, just multiply the constant matrix by the inverse of matrix A. Do well to complete each examples in the following slides. Another method you can use to solve the same simultaneous equation is the Cramer's rule. First, form the three matrices A, X, and B, and then find the determinant of A. To find X, substitute matrix B into matrix A. And to find Y, do likewise. Substitute matrix B into matrix A and divide it by the determinant. Finally, find the determinant of X and Y. Look at this example. You could see that the constant matrix B is substituted into A for X and Y at the same time, and the determinant divides them. Please take note of how the constant matrix B is substituted in X and Y. We come to the end of our lesson for today. For any question, please don't forget to WhatsApp or call. Thank you for watching. Goodbye.